Okay, in this lesson we're going to look at patterns and see if we can find a graph of the pattern and an equation that represents the pattern. So here we have three diagrams, figure 1, 2, and 3, and we want to look at the pattern and see what stays the same and what changes. Okay, so I'm going to color this first diagram. This is the original diagram. Okay, so let's see what this looks like here. If I color the same squares here, in diagram 2, and then I'll do the same in diagram 3. So I'm just coloring what stays the same. So this is the part of the pattern that is the same. The part that is different is in diagram 2, I'm adding 2 squares to the top, 2 to the bottom. So I'm adding 4 new squares here, and then here's the 4 that I added in diagram 2, and then I'm adding another 2 to the top, another 2 to the bottom. So we could create a table of values. So what stayed the same were the blue squares. And there are 1, 2, 3, 4, 5, 6, 7. So in this original picture, there's 1, 2, 3, 4, 5, 6, 7 squares. So in figure 1, there are 7 squares. In figure 2, we added 4 squares. So I'm just going to write here, we add 4 squares. So in figure 2, there are the original 7 plus another 4. So in figure 2, there are 11 squares. In figure 3, we added another 4. So now we have 15 squares in figure 3. 2, 4, 6, 8, 10, 12, 13, 14, 15 squares. Okay, so I would expect in figure 4 to add another 4 squares, so that would be 19 squares. So what stays the same is the 7, and what changes is we're adding 4 to each diagram. So you could graph this also onto a grid. So the x-axis would represent the figure number, and then the y-axis is the number of squares. So I'm just going to put an x-axis here and a y-axis here. And we're going to plot the point 1, 7. Let's do this in red. So let's put some numbers here. We should put some numbers on our axes. So let's do figure 1, figure 2, 4, and we'll go up to figure 5. Okay, I think I'll go by 2s on my y-axis just because my numbers are quite large. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. So I don't have to write every square, but I'm indicating by putting in 10 and 20 that each square is representing 2. So 1, 7 would be approximately here. 2, 11 would be approximately here. 3, 15 would be here. And 4, 19 would be here. So I can see that it is a linear relation. The points are going to go in a straight line. I'm not going to join the points because I can't have values in between. I'm not going to have 1.5 figures. It's either figure 1, figure 2, figure 3. So they are discrete values. We could also go back to 0 by subtracting 4. So if we wanted to plot a point on the y-axis, we could say, well, 7 minus, if we continue this pattern, which is going up by 4, we could also go back by 4 to find the starting point, which is approximately here. Okay, so if we were drawing a line, we wouldn't put a line through the points because they are discrete, but they have a linear relation. We could also find an equation that describes the pattern. So since it is linear, we know it's y equals mx plus b. Remember that m is the rate of change, which in this case is 4 because they are changing by 4 every time. So I know it's y equals 4x. And then b is the initial value. Well, the initial value is always at 0, so it's not necessarily the 7 figures that we start with. We want the value that is at 0, so that would be 3. So my pattern would be 4x plus 3. And then you could always check in the equation by using some of these values in the table. So we knew figure 1 had 7 squares. 4 times figure 1 is 4, plus 3 is 7. Figure 2 had 11 squares. 4 times 2 is 8, plus 3 is 11. So the pattern is confirmed there. Figure 3 had 15 squares. 4 times 3 is 12, plus 3 is 15. So all those match the pattern. So I could say, well, what would be in figure 5, the next pattern? So I'd expect it to have 23 squares. 19 plus 4 is 23. So the pattern continues. So what you're looking for in the pattern is it linear or nonlinear? How is it changing? Your rate of change we can find using these first differences. And then the initial value is always from 0. Okay, here's another pattern. So what stays the same? We've got 2, 4, 6, 8, 10, 11 squares are in figure 1. 2, 4, 6, 8, 10, sorry, 12 squares are in figure 1. If I draw figure 2, here's the original 12 squares. 2, 4, 6, 8, 10, 11, 12. So how many squares did I add? 1, 2, 3, 4, 5. Okay, so that figure had 12 plus another 5 is 17. And then let's draw here 1, 2, 4, 6, 8, 10. There's the original 12. Then we added 5. 1, 2, 3, 4, 5. And then how many did we add to the next one? 1, 2, 3, 4, 5. So we added another 5 there. So 17 plus 5 is 22. So I would expect figure 4 to have another 5, which is 27. So each time we are adding 5 squares to the picture. That is my rate of change. So what stays the same? What stays the same are the blue squares. Let's do that in blue. So what stays the same are the blue squares. There are 12 of them. And then what's changing is we are adding 5 squares each time. So we could go back to 0. We know they're going up by 5, so let's subtract 5 from 12 and we get 7. So the rate of change, we are increasing by 5 each time. The initial value is 7. So if I'm writing a pattern, remember that m is the rate of change, b is the initial value. So my pattern would be my rate, I'm going up by 5 every time. The initial value is 7. Okay, if I were drawing it on a grid, I could plot these points on the grid just to confirm that it's linear. So 0, 1. So at the bottom we're putting the figure number. On the side, I think I'll go up by 5s, 5, 10, 15, 20, 25. Just because the numbers are bigger. Okay, so at 1 it was at 12, which is about here. 0 at 7, which is about here. 2 and 17, which is approximately here. 3 and 22, which is approximately here, and 4 and 27, which is approximately there. So I can see that it's linear. They're going in a straight line. It's a positive correlation. I know the pattern is that we're increasing by 5 each time, and we're starting at 7. So how many squares would be in figure 6? I would just do 5 squares 6 times, plus the original 7 is 37 squares. So once I have determined the pattern, I can figure out how many squares can be in any figure. Okay, here's another pattern. So the original picture has 4 squares. So here's the original 4. 1, 2, oops, not that one. 1, 2, 3. There's the original 4. And I'll draw them in this one too. There's the original 4. So that's what's staying the same. So the blue squares stay the same. There are 4. And then in this figure 2, we are adding 1, 2, 3, 4. So now we have 8. And then in figure 3, here's the 4 that we added in figure 2. And then figure 3, we're adding another 4. So each time we are adding 4. So 12, 16. Each time we are adding 4 squares to the diagram. So we could go back to 0 by subtracting 4. So 4 minus 4 would be 0. So my rate of change is that we are adding 4 squares each time. And the initial starting point would be 0, 0. So my pattern, I'm starting at 0 and I'm adding 4 squares each time. That is my pattern. And again, we could draw these on a diagram, on a grid. So we've got 1, 2, 3, 4. It goes up to 16. So let's go 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. And then I'll plot those points. 0, 0. Figure 1 had 4 squares. Figure 2 had 8. Figure 3 had 12. And figure 4 had 16. So again, it's a linear relation, going up by the same amount. That's what we want to look for in that table. Can we continue the pattern? Yes, we can, and we did. What was the equation? It was 4x plus 0. How many squares in figure 20? So now we can just do 4 squares 20 times, starting at 0, would be 80 squares. So once we have that pattern, we can determine any figure number. And then here's the final one. So now we have 3 stars. So here's the original 3 in each figure. And then, so figure 1 has 4 stars. Figure 2, we added another 2. So now it has 6. So here's the 2 we added in figure 2. Then we add another 2 in figure 3. So we're going up by 2. We can plot these onto a graph. So figure 1, 2, 3, and 4. This is the figure number. And we had figure 1. Oh, we need some numbers on our y-axis. So 2, 4, 6, 8, 10. So figure 1 had 4. Figure 2 had 6. Figure 3 had 8. And figure 4 had 10. So I could continue that pattern. It's going up by 2 every time. So on the table, I can go to 0 just by going down 1 or down 2 and 1. So I could figure that, or I could subtract 2. So 4 minus 2 is 2. So at 0, it would be 2. So my rate of change is going up by 2 every time. So remember our model, it's a linear function. So M is the rate, which is going up by 2. B is the initial value, which is also at 2. So my equation would be each figure is going up by 2 squares, and we started with 2. And then we could use that to answer how many stars are in figure 11. So we're increasing by 2 11 times is 22, plus we started with 2 would be 24. So you should be able to look at a pattern, see what stays the same and what changes. What changes is the rate. And then you can determine, once you know the rate, you can determine the initial value by going back to 0. And then you'll be able to find the equation of the pattern.